And the best way to classify it is to find the length of each side. So you really want what a lot of students don't remember is that you have to go left to right. So it's like F to E, E to D, and then F to D. And we've got to find the distance between them. So there's two ways to do that. The first way is the distance formula. The second is to draw a triangle and use the Pythagorean theorem. Do either of those sound familiar to you?
Pythagorean theorem, Mary.
Yeah, I think it's gonna be a little better, and it lends itself well to this drawing here. So this side is 1, this side is 6. Can you find that third side for us, please? And it's if you remember, it's a squared plus b squared equals c squared.
Hmm. Okay,
So like a in your problem, a is 1, b is 6.
A is 1, B is, okay.
And you don't have to simplify, you just have to, square and add together.
Hold on, my phone calculator doesn't have an option for the power of two. But is power of two just like the number times itself?
That's exactly right. Now there's a better calculator. Let me go
Okay,
ahead and put this in the chat
okay,
here.
wait, but okay, A is 1. What did you say B was again? What number was that?
The two lengths are 1 and 6.
Oh, 6, 10. It's 36.
Okay, so
A plus 36. 1 plus 36.
so what is that?
That's a 37.
Right, so that's the square root of 37. Okay. So we can do the same thing from like E to D. We can draw this triangle here. It's got side 3 and then length here, and you're just counting 1, 2, 3, 4, 5, 6, 7, 8. So same idea. Could you square both of those legs for us?
So 3 and
Looks like
7?
8, like 8
8.
to me.
3 and 8. So 9 and 47. That means
Okay.
64.
Yeah, there you go.
Okay, it would be the square root of 73.
Okay, so far they're different. Last one here, you'll notice we're about to create a rectangle. You're just counting. There are other ways to do it, but you're basically just counting. This is 10 though, and this is 11 for your sides. So could you calculate the third length for us, please?
Okay, so it'd be 100 plus 121.
Okay, what does that
Okay,
become?
132. Square root of 132.
11 squared is 121 plus 100 is
Yes, 100 plus 120. Oh, it's 221. Oh,
yeah. And notice that they're all different. You don't have to actually calculate them. They're all different. So this is a scalene triangle. It looks obtuse. I don't know if your teacher would expect that, but you can sort of visually see it looks, this last angle here looks bigger than 90. All right, so sometimes um they look like, oh, they might not be that much work, but this one was a fair amount of work. Okay, so here's a new problem for us to do that's basically the same. We're going to draw, let's see here, negative 410. All right, so here we go. So here's our origin. D is negative 2, 3, 1, 2, 3. There's D. E is 5, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. So that's E, 5, comma 5. Negative 2, comma 3, that's D. And then negative 4, 10, 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
I hope you don't mind me asking, but how long are we going to do this for?
We're going till about 6:10, unless you want to cut it short. That's up to you. Figured that'll get us the full time for today.
Are we going to like 6:05?
Sure.
All right, thank you.
So it's the same thing here. You've got to calculate F to D, F to E, and then D to E. You got to go left to right here. It's really important. So get rid of this one here. Really a good idea to draw those triangles again. That's 2, and that's 7. Could you calculate that third length for us, please, using the Pythagorean theorem again?
So is 2A?
Can be, yeah. The legs are interchangeable.
Yeah, it would be a square root of 53.
Okay, agreed. And then let's go F to E. So that's this triangle here. So we got 5 and 5 on that one.
Well, okay, it would be a square root of 50.
Okay. And then for that last one there from D to E, it's like 2 and 7.
Oh, that would just also be 53.
Yeah, so when two of the segments are the same, do you remember what kind of triangle that is from the other day?
That's the not equilibrium thing. Hold on. That's the isosceles.
This is an isosceles, and looks to be acute. Well, I couldn't guarantee that. Well, it could be
Which one are you looking at?
this triangle. It's definitely isosceles, like we mentioned here.
Mhm.
Um, because
It could be
because
acute. I think it's acute.
yeah, I mean we'd have to actually calculate the slope of these lines to know further, but I don't know if you guys are doing that. We can, may not be clear. May not be that's needed. So all right, let's look at number 12 here. So it says triangle JKL is an equilateral triangle. JK is 13x plus 5. KL is 17x minus 19. and that's 8x plus 35. What do you remember about an equilateral triangle?
Equilateral. It's all sides are equal.
Yeah, so you can set any two of those equal to each other and solve for x. So I'd like you to do that. Set any two of those equal and solve for x.
Wait, like one of the equations? Like I gotta.
Any two sides, any two equations equal to each other.
Uh, I don't remember how to
What
do
two
those.
equations did you use?
Uh, 8x plus 35 and 17x 8 minus 19. I forgot how to set it up.
So you're setting them equal to each other like this? Did you write anything down like that?
Oh, there we go. No, sorry, I forgot how to
So you move the variable from
like
the
write it out.
smaller side to the larger side.
So, so that would be 8x minus 7x.
You're subtracting from the smaller side to the larger side.
Oh, yeah, 8x minus 7x. And same thing with the other numbers. So that'd be 19 minus 19 and 19 minus 35.
So 35 equals 9x minus 19. Do you remember what to do from here?
Yeah, then you uh hmm, do you divide by 35? No,
You add 19 to both sides.
no, you add 19. Yeah, I guess that would be 38.
Nope, not 38. 35 plus 19,
Oh, no, I was talking about the 19 plus 19.
but it's
Sorry.
negative. That's why you add it to undo the subtraction so that it cancels.
I didn't notice that. Sorry. That'd be 54.
Okay, and then now you divide by the number in front of x. What is the number in front of x?
That'd be 9. And that'd be 6. X equals 6.
Good. All right, so if that is correct, we should, when we put it back in, get the same value. So let's do that. 13 times 6 plus 5, calculate that. 17 times 6 minus 19, and then 8 times 6 plus 35.
Times.
So could you calculate
First,
each of those for us?
okay, the first one is 83.
Okay,
Right, the second one is also 83.
okay.
And it was also 83.
We expect that because they're all the same. All right,
Yeah.
we're gonna skip 13 and go to 14. It'll be a little bit more doable in the time we've got left. 14 is a isosceles triangle, and they tell you, and this is very important, they tell you that uh, C to D is congruent to D to E. That's very important. You have to know which are the congruent sides. So CD is 9x minus 25, and DE is 6x plus 8. These are the two congruent sides. So these are the two equations that you're setting equal. All right, so just like the previous problem, you want to move the variable from the smaller side to the larger side.
Mhm.
So give that a try, please. See if you can solve for x.
It was an add or subtract.
Well, is 6x positive or negative?
It's positive, so it would be
So you undo addition with subtraction.
okay. That would be 3.
3x minus 25 equals 8. And from here,
Wait about the but then we add the 25. Wait, no.
okay,
Wait, yeah.
so what does that become on the right?
33.
Okay. And then how do you solve for x?
And you divide that by 3,
Okay, so
which would be
x is
11.
good. So now you got to put that 11 back into both of these equations.
Yeah. Okay, so the first one would be 74.
Okay, good.
I don't know what the second one. What's that numbers are? Can you
Six,
like
six, 6 times 11 plus 8.
can you scroll down, please?
There you
Thank you.
go. All right.
That would be 74.
Good. And then the last side you have to find is the CE, which is 10x minus 73. It will not be 74 because it's not congruent to the others.
And that would be isosceles.
Right. You can calculate that third side for us, 10 times 11 minus 73.
That would be 37.
7. Good. All right. So that is all the sides. That's everything it asked for. So we left off 13 and 15 still remaining. So we'll get to that, whenever maybe you can knock those out in class.